This video is part 2 of the exponential growth and decay lesson. We had a little introduction before. Now we're just gonna look into a formula to use to figure out an amount based on initials, how many years, and what the growth or decay rate is, and attempt a few examples. So just before we do, I want to make sure that you guys are aware that P.A just means per annum, annum meaning year in Latin. And this right here is the exponential formula. And there's all these different letters that have been put into here. I don't want to go into how this formula has been created. All we need to know are a few of the things as follows. You'll notice that there are two A's, one A by itself and an A with a little zero next to it. The first A just means the amount, okay? So before in the part 1, which I highly recommend that you watch, we're talking about a population growth. If we're talking about population, the A is just the amount of people, maybe after a certain amount of years, depending on what the growth is, okay? So A stands for amount. It's gonna be people, dollars, value of something, does not matter. Now, the difference between A and A0 is that A0 is the initial amount. And we use the number 0, which is called a subscript. Okay, it says here, subscript, just to indicate that, okay, if we want to get the amount of something, we need to talk about what the initial amount is. So the question will always give you the initial amount. In our previous example, the initial amount was 10,000 because that's how many people started off within the town. All right, so A0 is initial, and we use 0 because this just means the 0 time frame, the starting time frame. We don't put 1 because 1 will then indicate after 1 year. So we have to use 0 just as a general rule of thumb. The R is considered the rate, okay, and generally given as percentage within a question. And this rate is always going to be over 100. And then the N, sometimes denoted as the letter T with a meaning time frame. The N just stands for how many time frames. How many time frames. Generally given in year. Sometimes it could be within a certain amount of months or days. Just depends on the context of the question. Okay, so these 4 things will always be given to you within a question. Okay, if you want to find the amount, specifically these 3 things, If you want to find the amount of something, give me a starting amount or initial amount, give me the rate, and give me how many time frames, so maybe 2 years, 3 years, 10 years. I can plug it into this formula and give you the final amount after however long. Okay, that's all there is to it. Now you notice that there is these plus and minus symbol. They just use it as a shortcut. If we're talking about growth, we add it. Okay, so we 1 plus R of 100 to the power of N. If we are talking about decay, we minus it. That's the main difference. Okay, so look at the first example. We're first going to write rules. So we're not necessarily going to work out anything. We're going to write rules so we can be formalized with what's going on. For exponential rules, for the following situations, form exponential rules. John has a painting that is valued at $100,000 and it is expected to increase in value by 14% per annum. So with question A, there are a few things we need to know. That we already know, sorry. We already know that the initial amount, so A0, or A subscript 0, is $10,000. This is how much this painting is worth at the start. Okay, it's valued at this amount, and it's expected to increase, so our rate is expected to increase by 14% per annum per year. So after 1 year, it's going to be worth 14% of this amount, and that will be added to the initial painting. And then after 2 years, we find this new amount that we just have, and then apply 14% of that new amount, okay? Now, we want to write a rule for this. So again, the formula for this is A is equal to A subscript 0 Okay, so go back here. A subscript 0, open bracket. Now, where it has that open bracket, there's just this invisible times that's there, okay? 1 plus r over 100 to the power of n. Now, what we do know is we know what a of 0 is, the initial amount. And we also know what our rate is, which is 14 over 100. But what isn't given to us is our n value, how many years. And the reason why is because we're just coming up with a rule, okay? So this rule says, hey, this is the formula to determine what the value of this painting will be after n amount of years, okay? Or n amount of time frames. We don't know how many time frames, but say for instance, we want to know what the amount is after 10 years, we can put 10 instead of the letter n, put this rule into our calculator and work this out. So just out of curiosity, if you get your calculators out, if you want to say 10 years, we would put 100,000 times, open bracket, 1 plus fraction 14 over 100, close the bracket, make sure you go across on your cursor. Now we want to put a power, because in this case we want to put to the power of 10. So we just press this button here, put 10, and this is saying that after 10 years, if 14% of this is increase in time, 14% each year, we're expecting this to be $370,722.13, which is quite a lot of money just after 10 years, okay? That's exponential growth. That goes up quite substantially high, okay? So the rule, that's a rule. If you want to, you might see the answers in the back come up with a rule as A is equal to 100,000, open bracket, 1.14 to the power of m. The reason why they do this is because 1 plus 14 over 100 is 1.14. That's just converting it into decimal format. 1 plus 14 over 100, press SD, 1.14, okay? I don't mind which way you do it, as long as you get the answer correct, but if you want to be super careful, you can put into this format. Question B, a city's initial population of 50,000 people is decreasing by 12% per year. So, we know that our initial is 50,000 and our rate is 12%. Now, the key word here is decreasing. So it's a decay. So they're losing 12% of the population per year. So it's going to keep going and going and going down. Again, the rule, I'll just copy this one here. A is equal to what our initial is, 1 plus 12 over 100 to the power of n, or if you want to make sure that it's the same at the back of the book. Now, I've just made a mistake because I'm so used to exponential growth. This is a decay. This is a decay, so we have to use a minus. Okay, we have to use a minus, not a plus. That one nearly got me. So 1 minus 12 over 100. As a decimal, that will be 0.88, I believe. And that will be to the power of n. I'm second guessing myself. 12 over 100. 0.88, awesome. And that's the other format of writing it, okay? Now, this is just the rule, all right? Once we got the rule, we can then use that rule to go ahead and answer a question that looks like this. And this will be the last example.
House prices are rising at 9% per year, and Zoe, shout out to Zoe, Zoe's flat is currently valued at $600,000. We're going to look at determining a rule for the value of Zoe's flat in dollars in N years time, and then we're going to use that rule to determine what the value of the flat will be within 1 year or the next year, and then in 3 years time. This is easy, it's a piece of cake. What we do know is that they've used V, so let's just keep it consistent. The value, the initial value, is $600,000, and it's rising, so we've got exponential growth. So our V is going to equal 600,000, open bracket, 1 plus, now the rate says 9%, so it's 9 over 100 to the power of n. There's our rule. Very, very simple. And then with this rule, with BI, what will the value of a flat be next year? So we're going to find the value V when n equals 1. Now, if you want to be technical, we're technically finding V of 1 because the value after the first year should be subscript 1. Okay, if we're finding it after 10 years, it'll be V subscript 10. So we're finding V1 when n is equal to 1. So we just plug 1 into here, which is just technically anything to the power of 1, it just stays the same. So on your calculator, it's 600,000 multiplied by 1 over 9 over 100, multiplied by 1 plus 9 over 100 rather. 600,000 times, open bracket, 1 plus 9 over 100, close bracket. So after 1 year, it will be worth 654,000. 654,000, yeah. So what this has just done is it's found out 9% of 600,000, which ends up being 54,000, and it just added it on to the first year. But then in 3 years time, it's gonna find 9% of this, and then another 9% after the next year to determine how much it's gonna be worth. So in this case, we're gonna find V of 3, because 3 years, when n is equal to 3. So this is gonna be same formula, 1 plus 9 over 100, but this time the power is 3. So 600,000, got one too many zeros, there we go. 600,000, 1 plus 9 over 100, close bracket, power button here, 3, SD, 777,717.40. I see that 0.4 because we're talking in the context of money. We just got to make sure that we're not leaving it as 4 cents because that should be 0.4, but rather 40 cents. Now look at the difference. 600,000 after 3 years, it's gone up by $177,017.40, quite a bit, just at 9% per year. And that concludes this video. That's part 2, and that will be the last video you'll need to watch for the index laws unit. Best of luck of getting your work handed in regards to the test. Still not too sure what the approach will be because I'm creating these videos in week 1. So until then, just keep your heads in tune, see what's going on, check your Microsoft Teams channel or chat or Compass, read your emails, you'll find out soon. Until then, see you soon. Take care and bye-bye.